Welcome back to The Explainer. I am so thrilled you're joining me today because we are tackling this completely fascinating intersection of heavy industry, environmental science, and corporate accountability. Today, we're zooming in on exactly how the world tracks the environmental footprint of coal mining. And, we aren't just looking at vague PR claims here. We are digging into the rigorous, quantifiable sustainability standards set by the SASB. That's the Sustainability Accounting Standards Board. We're going to see exactly how multinational corporations are forced to measure their impact literally down to the very last metric ton.
Okay, let's dive right into this. What we're looking at right now is a piece of an actual SASB accounting table. And I want to be clear, this isn't some glossy marketing brochure. These are the real, mandatory metrics that coal operations use to report their environmental impact to investors and auditors. It's basically a universal language of sustainability. By standardizing these disclosures, stakeholders can clearly, apples to apples, compare how different companies are managing the immense environmental responsibilities that come with resource extraction.
So, here's our roadmap for today. We'll start with tracking the mine's waste, then move to categorizing it by metric tons, look at the acid rock threat, and finally, protecting global biodiversity habitats. Let's get to it. Section 1. Tracking the mine's waste. This is really the ground zero of coal operations. To really grasp the environmental metrics of coal, you first kind of have to accept one simple truth. Coal extraction is an inherently messy, volume-heavy business. At an active coal mine, you aren't just dealing with the coal that gets shipped off to a power plant. You're dealing with staggering volumes of process refuse, liquid coal waste, solid rock, and clay. Literally, for every ton of usable coal, mountains of earth and byproduct are moved, processed, and just left behind. This undeniable physical reality on the ground is exactly what the SASB waste management metrics are designed to capture. And honestly, this right here is exactly why the financial world is paying such close attention. The SASB standard explicitly states, and I'll quote it, "Improper disposal or storage of hazardous materials or mining waste can present significant long-term threats to human health and ecosystems." So this isn't just a purely ecological issue, it is a massive financial liability. Contaminated groundwater or, say, a breached storage facility, that can lead to staggering remediation costs, brutal regulatory penalties, and complete operational shutdowns. Investors and auditors absolutely demand to know exactly how this waste is contained. Moving on to Section 2, categorizing by metric tons, essentially how we sort this massive physical footprint. Now, what's really interesting here is that a company can't just report, hey, we have a lot of waste. It must be rigorously classified. So how do you actually measure a literal mountain of waste? Well, imagine a giant mixed pile of mine refuse. It has to be systematically separated into 4 distinct measurable piles. Every single ounce is accounted for, and the whole shebang is tracked by total weight in metric tons. Let's break down how the SASB defines these 4 specific piles. Okay, pile number 1 in our sorting process is non-mineral waste. According to the metric, this is material for which the entity has absolutely no further use, so it's discarded. Think of the raw industrial byproduct of running a massive mining operation. Scrap metal, used oil from the machinery, worn out loader tires, batteries, you name it. But notice what's missing here? This category strictly excludes actual rock and dirt. It's measured purely in metric tons of industrial garbage. Our second pile is what the industry calls tailings. Tailings are basically the mineral residue and liquid waste left over after you've washed and extracted the target coal. This stuff is often stored in these massive impoundments or ponds on site. And yep, just like before, companies must report the absolute total weight of these tailings produced, right down to the metric ton. Then we have the third massive pile, waste rock. Think about it. When you dig down to reach a coal seam, you inevitably pull up a ton of earth that simply isn't valuable. This is mineral material and low-grade ore with target minerals and concentrations way too low to bother recovering economically. It's essentially the rock that was just in the way. And again, this literal mountain is measured and reported in metric tons. And finally, we get to the most dangerous pile of the bunch, hazardous waste. This category includes elements explicitly defined by local and international frameworks as toxic. In coal operations, this can mean waste containing heavy metals like mercury, arsenic, or cadmium. This specific tonnage is scrutinized so heavily because it poses the absolute greatest immediate threat if it's mishandled, which actually brings us perfectly to our next critical topic. Section 3, the acid rock threat. This is where physical waste becomes a very real biological hazard.
So we're zooming out just a little bit now to see what happens when physical tonnage becomes a biological hazard. There is this absolutely crucial bridge between the raw physical metric tons of tailings or waste rock we just talked about and the terrifying reality of toxic runoff. See, it's one thing to have 1,000,000 tons of waste rock just sitting on a site. It's another thing entirely when rainwater hits that rock and begins to seep right into the local groundwater supply. This phenomenon actually has a specific, highly monitored name: acid rock drainage, or ARD for short. The SASB standard notes this as a particularly concerning effect of coal operations. Basically, ARD is created when surface or shallow subsurface water encounters coal mining overburden. A chemical reaction triggers, contaminating the water with heavy metals and rendering it highly acidic. This runoff is devastatingly harmful to humans, local animal populations, and vegetation. It's serious stuff.
Because ARD is just such a severe risk, the reporting metric forces companies to be incredibly transparent. They can't just wave their hands and say they are handling it. No way. They must disclose the percentage of their mine sites that fall into 3 specific escalating stages. Stage 1, where ARD is predicted to occur based on chemical evaluations. Stage 2, where it is being actively mitigated. And Stage 3, where the damage has already occurred and the site is actively under treatment or remediation.
But, what does actively mitigated actually look like in the real world? Well, these SASB standards give us some concrete examples. It means a company is actively storing or covering sulfite-bearing minerals so they simply don't have the chance to oxidize. It means building robust flood prevention infrastructure and physically sealing up mines. It can even mean using chemical treatments, like deploying organic chemicals designed specifically to kill off sulfite-oxidizing bacteria. Auditors want to see these physical, tangible steps in action. All right, on to our final section, Section 4. Protecting global biodiversity habitats, the macroecological picture. Let's move to the macro level and see how this all builds together. We are pulling up the actual SASB document again, focusing specifically on the metric that governs biodiversity impacts. This is exactly where the gritty accounting of dirt and runoff intersects directly with massive global conservation efforts. So the SASB literally requires companies to cross-reference their entire operational footprint against specific, highly protected ecological zones. We're talking about IUCN protected areas, UNESCO World Heritage Sites, Europe's Natura 2000 network, and Ramsar wetlands. If a company wants to mine coal, they have to publicly, transparently declare if their reserves sit inside any of these globally recognized sanctuaries. And guys, it goes a step further than just drawing a few lines on a map. There is a very strict 5-kilometer radius applied around specific habitats. The standard defines being near an endangered species habitat as being within 5 kilometers of areas where species on the IUCN Red List, specifically the ones classified as critically endangered or endangered, are known to exist, breed, or frankly, even just migrate through. So here is the absolute crucial point. The metric demands that these entities publicly disclose the exact percentage of their coal reserves located in or near these fragile hotspots. And it doesn't stop there. They have to break it down by proved reserves, which is the coal they know for a fact is there and is economically viable, and probable reserves, the coal they are reasonably sure is in the ground. Now, you might be wondering, why does this matter so much to the financial world? Well, for an ESG investor, or really any financial stakeholder, this isn't just about saving nature, though obviously that is absolutely vital. It is about severe financial risk. If a high percentage of your proved reserves sit right next to a UNESCO World Heritage Site or a critically endangered habitat, you are facing massive regulatory barriers. You risk delayed permits, skyrocketing extraction and compliance costs, and the very real, terrifying threat of stranded assets, meaning coal that you own on paper, but are legally or socially forbidden to actually mine. And honestly, that just brilliantly illustrates the power of these metrics. We've literally gone from sorting metric tons of scrap metal to protecting the migration paths of endangered species, all through the lens of standardized accounting. It leaves us with a pretty massive question to ponder. If we force companies to map every single metric ton of toxic waste against the world's most fragile ecosystems, will this level of radical financial transparency finally tip the scales toward genuine, lasting corporate accountability? It's a question the industry and the entire world is answering right now. Thanks so much for joining me on this explainer. Keep asking those big questions, and I'll see you next time.